We were given the winds aloft at that 5,500 foot cruising altitude of 190 at 15. So going to the wind side of our E6B, we need to go ahead and make our wind dot. I went ahead and spun 190 under our true index, and now we just need to count up 15 knots. So my grommet is on the 100 to serve as a reference. Then I'm going to come up 15 knots, and I'm going to make my little wind dot, my X, right there on the 190 at 15. Now we're ready to go ahead and spin in all of these true courses to get the appropriate wind correction angles based off of that true airspeed that we calculated of 114 knots using those performance charts earlier. So let's go ahead and find the wind correction angle for Evansville to that top of climb. So in this case, our true course is 033. So we'll go ahead and spin in 033 under our true index. Now remember, for our actual climb, we are climbing at 73 knots. So in this case, we're going to move our wind dot down to that 73 for that Evansville top of climb. Park it at about 73. We can see we get a wind correction angle of looks to be 2 degrees to the right. And we get a ground speed, reading that of the grommet. We can go ahead and call that 87 knots ground speed. Now, because we already did get the time, distance, and fuel to climb from the charts, we don't have to perform that calculation down here. We'll just have to go ahead and come up with what our actual compass heading will be from our initial departure to that top of climb. So while we got the video rolling here, we'll go ahead and just spin in the winds for that top of climb to Petersburg. In this case, we saw that our true course is going to be 020, so we'll park that under the true index. And we'll use that cruise true airspeed of 114 knots. So we'll go ahead and move our wind dot up to that 114. Almost there. Forgive me, hard to do one-handed. So there's that wind dot there at 114 knots. We can see we've got a wind correction angle of 1 degree to the right. And now I'll read our ground speed underneath our grommet. We can see our ground speed for that particular leg. We'll just go ahead and call it 130 knots. So we'll jot it in right there. So now what I want you all to do on your own is grab your E6B, and I want you to come up with the wind correction angle and the ground speed for the remainder of those navigation checkpoints. So take a little bit of time to do that, and we'll run through the answers here in just a sec. So I just spun in the rest of the winds for the rest of those legs there. So from Petersburg to our lake waypoint, we came up with a wind correction angle of 3 degrees to the right. Reading our ground speed under the grommet, we got a ground speed of 127 knots. From that lake waypoint to that Cincinnati waypoint, we got a wind correction angle of 4 degrees to the right. Again, our ground speed was coming in at 127 knots. And from the little town of Cincinnati to Bloomington itself, we've got a wind correction angle of 3 degrees to the right and a ground speed of 127. So now that we have that wind correction angle, we'll come over here on the chart and we'll go ahead and look for one of those isogonic lines. All right, pretty easy here. We have one running right along our route of flight. So we'll find that isogonic line to get our magnetic variation. We can see our magnetic variation along that isogonic line is going to be approximately 4 degrees to the west. So we'll go ahead and apply that for our variation. And then we'll run through all of these little equations here to come up with a compass heading for each individual leg. So using that plus 4 degrees right variation, correction 4 degrees to the west for the variation, go ahead and come up with the course headings, the compass headings for each of those individual legs. So line by line here, we'll go through these. We've got our true course for Evansville top of climb is 033. We've got our wind correction angle of 2 to the right to give us a true heading of 035. Take into account that 4 degrees west variation, so we'd add the 4 degrees to give us a magnetic heading of 039. Again, for planning purposes, we'll just go ahead and assume deviation is 0, which gives us a compass heading for Evansville to the top of climb of 039. Running through it again for each individual line of the navigation problem here, we get a compass heading for our top of climb to Petersburg of 025. We get a compass heading of Petersburg to the lake of 045. From that lake to the little town of Cincinnati, we'll get a compass heading of 051. And then for Cincinnati to Bloomington, running through the equation, we get a corrected heading, compass heading of 047. So again, the true course plus the wind correction angle, since it is to the right, plus the westerly variation with 0 deviation, that's how we come up with those compass headings. Now we have the ground speed for each individual leg and the distances, so it's time to start crunching our time and our fuel en route for each of those individual legs. So because we've already got the values from the charts from our point of origin to the top of climb, we'll go ahead and start these calculations from top of climb to Petersburg. We calculate our ground speed to be 130 knots, and our distance we said was 20 nautical miles. So going to the calculator side of our E6B, we want to put that ground speed over that 60 index. So here we are with 13, that's going to represent our 130. Going around the A scale, we're going to find that 20 nautical miles. There it is right there. We come to the inner scale, and we can see that's going to be 9.1, about 9.2 minutes for our time. So now we can go ahead and go through and calculate all the times for those respective legs. So everybody grab your E6B and come up with the times for those legs, and then I'll come through and I'll show you what answers I came up with. So here's the answers I came up with for those respective times. From Petersburg to the lake, using the ground speed of 127, the distance being 21 nautical miles, came to a total time of 9.9 minutes. To travel the 20 nautical miles from the lake to Cincinnati at 127 knots ground speed, approximately 9.5 minutes. And then for our last leg there with a ground speed of 127, going that 10 nautical miles, puts us at 4.6 minutes. All right, so we do have that fuel burn that we calculated from the performance charts, which we said was going to be 9 gallons an hour. Now we can take that 9 gallons an hour and calculate the fuel burn for each respective leg. So just like before, we're going to want to put our fuel burn over our 60 index. There it is, 9 gallons an hour over the 60 index. And then we're going to use our B scale, our time index, to calculate the individual fuels. So we said that first leg, the top of climb to Petersburg, was going to be about 9.2 minutes. So we'll find 9.1.2 will come out. We see that comes out to about 1.38 gallons. We'll just go ahead and round up that fuel for that particular leg to be 1.4 gallons. All right, so go ahead and take your E6Bs and run through the fuel calculations for all of the other legs using that 9 gallons per hour fuel burn, and then compare your answers with what I'll show you. All right, so for the top of climb to Petersburg, we came with 1.4 gallons. From Petersburg to the lake, if you spin it, it comes up between 1.4 gallons and 1.5 gallons. We'll just go ahead and round up. It's always best to err on the side of being conservative, so we'll just go ahead and round it up from that 1.46-ish to the 1.5 gallons. We'll do the same thing with the lake to Cincinnati leg. Came with 1.5 gallons of fuel burn. Then for our last leg, that Cincinnati to Bloomington, we came up with 0.7 gallons. If you want to round that up to 1.0 gallons, that's just fine. You're not going to be able to tell 0.7 gallons with the gauges in the airplane. So our next step is to go through and add all of the times and all of the fuels together to get our total time en route and to get our total fuel burn. We'll also add the distances together to get our total distance, and we'll compile all that information on the back. So go ahead and add up the distances for your total distance, the times for the total time, and the fuel for the total fuel required. And then we'll take a look at those numbers, apply the applicable VFR reserves, and then we'll be complete with this particular calculation. So here we are with our totals. Our total distance for this particular flight is going to be 81 nautical miles. The total time is going to be 41.2 minutes, and our en route fuel is going to be 7 gallons. Let's go ahead and add our VFR day reserve fuel, which is going to be at 30 minutes. So burning 9 gallon an hour, half of that's going to be 4.5 gallons. So our total fuel required to be legal for the flight is going to be 11.5 gallons. So that's that. Again, a little more complicated, a few more variables than what we're used to seeing, a lot of different calculations. So I hope everybody was able to follow along pretty well. If you weren't able to follow along or there's still some ambiguity, go ahead and reach out and we'll do our best to answer all those questions. All right, guys, that concludes our lecture for today, and that actually concludes our lectures for the week. So I hope everybody has a pleasant spring break. Enjoy the quarantine, and we'll see what the world has in store for us.